So this video will show you how to load a feature collection and then filter it by location. And so I'm going to copy the snippet and then paste it in here. And once again, I've kind of given you this initial constructor, the EE feature collection with this address, this string, that once again is a data set that I have in the Conservation Atlas. So this one is the Middlebury College parcels that we have in the geography department, and I've just brought it into Earth Engine to make it easy for us to work with it. So if I just say that the first thing I want to do is to look at the college lands, and just I took away the quotes there. So if I say I'm going to do this, and I'm just going to hide these for now because it might get mad that I haven't filled those out. What you'll see over here is that it's chunking along, and then there are 286. So once again, you can do kind of similar things to, I'm going to look at the first one, and then I might look at how many are in here, size. And so you can use, similar to what we've done with the image collections in the past, you can use these types of methods on the feature collection to get the first in the stack and to kind of quickly get a report on how many features are in this feature collection. What we want to be able to do, let's go ahead and look at it. So I'm going to say that I'm going to center the objects on college lands. So the maps center object, that method is, you're going to find it in here, center object. So it allows you to center a map on a given object, and it can be a geometry, image, or a feature. And then you can also define the zoom level. So if I say, please center the object on college lands, and let's say at zoom level 12, and I hit run, that should bring us into here. And I'm going to say, let's go ahead and set the options here to be hybrid. And then I'm going to ask to add college lands. And then again, this is a feature collection, so we have to say color. And I'm going to use the official Middlebury blue, I believe, which is this string. And we'll talk about this color code, this way of defining red, green, and blue in a little bit, but we're going to just hold off on that for now. And then this is college lands. And I'm going to once again just say false so that it doesn't, because we're going to create a lot of layers here, so I don't want them to draw automatically. I want to be able to control it. And then there are college lands. So that's actually the alternative blue, but this is the official alternative blue of Middlebury College. And if you are curious, and you may not be, but there's the visual identity system for Middlebury, which is going to tell you all about the official color and the official typefaces and so forth. So that's where I got this blue from. It's kind of it has better contrast on air photo than the darker blue. That's the official blue. Anyway, so there are all of the college lands, and it's pretty impressive how much land the college owns. They own 10% of the town of Middlebury. It's the largest landowner in Middlebury, I think, other than the federal government. And so let's go from here. I'm going to do one more thing. Oh, yeah, we need to filter by location. So the idea is that I want to grab just the college lands that intersect the Champlain Valley. So to do that, the easiest method is to go to the end here, hit return, and ask a couple times sometimes because it's not, sometimes it's a little funny and won't give me my cursor right away. And then I'm going to just hit tab because I like to indent when when I'm going to chain like this, and I'm going to say filter bounds. And so this is a quick method of a feature collection. It's basically a shortcut to filter a collection by the intersection with a geometry. And so I believe here I can just say filter bounds, and then I've got to feed it something, and I'm going to say region. And if I hit run, it'll kind of rerun here, and I should now have just the college lands that are in the region. And we talked about this in lecture, but this gets pulled because this one little part touches the region, so the whole gets grabbed. Is that fair? So now I'm going to save. That's how one method of filtering a feature location, filtering a feature collection by location, basically by the intersection with another um, feature collection or geometry. And moving on, I hit save. Let's